So, good morning and thank you very much to the organizers of this conference. So, first, I'd like to thank to SA Engineering and also IEEE Computer Society Chennai section, and to Dr. Kodi Soren, Dr. Nalini, HR Monsa, Dr. Sativil, and all the committee members. So today, the title of my talk is Application of IoT and WSN in Smart Agriculture Monitoring System. So basically, what I'm going to do today is give some brief introduction about IoT and WSN and also about agriculture system. Then I'll share with you two case studies. One is about mushroom cultivation, which is done in an indoor environment. And another one is palm oil pollination. That is on the outdoor environment. So we can see how these sensors, IoT is used in both world, indoor and also outdoor. And actually both these application, they have different requirement when you put indoor and outdoor. Okay, so outdoor, a lot of things you need to take care. The challenges are huge. For example, the environmental, the casing of the devices and things like that. You need to take care. Okay. So this is the contents of my talk. So basically, we talk about why food supply or agriculture will be a big demand, especially by 2050. And then why we need to modernize this agriculture, and of course some evolution of agriculture, like what happened to the industrial revolution. You have industrial revolution 1 to 4, so the same thing also happen in agriculture. Then a bit about agriculture 5 is a very knowledge based agriculture 5. Then also I'll touch a bit on the internet evolution, agriculture sensors, wireless networks, some architecture, only simple architecture to give you some rough idea how the architecture is developed for this kind of application. Then of course, being a robot, then I'll talk about the case study, issues, and finally the conclusion. So agriculture production must be increased by 70% by 2050 to fulfill the world demand, because the population will increase to almost like 10 billion by 2050. So we'll have a shortage of foods and things like that. Because why? Simply because for two reasons. One, the agricultural land that's occupied for agriculture is becoming smaller because the lands are taken over for development, building schools, building roads, building housing, residential areas, and things like that. And secondly, the number of farmers are also coming down, becoming smaller and smaller, because for example, if you take a farmer's children, say they got 3 or 4 children, I think most of them would become an engineer, lawyer, architect, or IT expert. Not many want to become an farmer. So the number of farmers also going down. So we need to think of way how to fulfill this 70% of food increase by 2050. So the alternative that we have currently is by using technology. These include technologies like internet, and also like sensors. These are some major technologies that we are going to use. And of course, there's also another technology currently used for a lot of agriculture application, which is the AI. So in this talk, I'll focus on IoT and WSN. So why agriculture transformation? So as I mentioned, the population will increase. By 2030, they expect like 10 billion of people. Okay, and then the effects of climate change, because due to the climate change, we cannot grow some of these crops at any time. So by using this smart agriculture concept, we can almost grow at any time, because you have the capability to control the environment. Say, for example, in a greenhouse, you can control the environment so that you are almost can harvest the crops almost all the year round. Then also using technologies, one of the reasons, because we have some of the latest technology, and the price of the technology is coming down so much that it's affordable. For example, the sensors, the network devices, all these things are coming down very much. And then also the automation has become one of the main driver in a lot of activities, including agriculture. This is the evolution of agriculture. You start with the manual method. If you go to the right, left, bottom part, you start with manual. Then you go to machines where we use tractors. Then we go to automation. In some cases, they use semi-automation, and now it's becoming a knowledge base. So this is what we call um, agriculture 5.0. Okay. Evolution, agriculture 1, as I mentioned, is very labor intensive. Then we move on to green revolution. Knowledge base. And in agriculture 5 will be fully AI based. Okay. And in some places or in some countries already taking place this agriculture 5. Okay. Then we'll look at the internet revolution, IoT. So it started in 69 and then slowly, gradually progressing, and now we have IoT. Okay, initially we see it's not called Internet of Things, it's called Internet of Morphine. Okay, and then in 2012 and beyond, it start finding term of Internet of Things. Okay, so basically, you use internet to connect almost all the devices that you need to communicate, you need to network. Okay. So this is a typical structure or three-layer structure we use for a lot of agriculture applications. So you have at the bottom part is all your sensors, gateway, all your hardware. Then we have the middle part. This is where all the um, decision support system, image processing, all these are done here. And finally is your top layer where you use your devices to access. Can be also a handphone, can be a PC, and even a tab for that case. These are the agriculture sensors. You have typically like temperature sensors, pH sensors, you have humidity sensors, you have moisture sensors. But not all the sensors will be used all the time. It depends on what parameters that you want to collect. So if you want to collect just the pH, then you just buy a pH sensor. But nowadays in the market, they have what we call integrated sensors like temperature and humidity. They bundle as one sensor, so you can buy that single piece of sensor, but you can collect both the data, the temperature and humidity. Okay, so they are working on many other sensors. Okay, like NPK sensors. NPK stand for the natrium, potassium, and kalium. This is to measure the fertilizer amount that exists in the soil. So if the particular component of the fertilizer is not enough, so you only need to put that fertilizer. You don't need to put all the three components of the fertilizers. If this potassium is less, so if you just focus on potassium, you just add potassium to the soil. This is a typical setup of a greenhouse environment. So here we are using like pH, humidity, soil moisture and temperature sensors. So you might be asking why we are using two temperature sensors. One is the soil temperature, one is the second one is for the ambient temperature. So this is how we use the temperature. These are basically the IoT and agriculture products. So there are increasing every day because the demand for agriculture application is increasing. These also include the drone. Okay, they use a lot of drone nowadays in some countries. If your piece of land is very big, so if you want to monitor, then you have to use drone and some other similar devices. Okay, this is a wireless network. So when you do a agriculture monitoring system, you need to know what kind of wireless network that you want to use. In some cases, you can be simple Bluetooth or Zigbee. I mean, if the distance between your farm and your control center where you capture the data is a short distance, then you can use a short range wireless networks. But if the distance is far, then you should go for LoRa and also Sigfox. But you have to remember these networks, when the distance is far, it consumes more power. Okay, so that means your battery or whatever solar panel you are using, you need to able to support this kind of long range. Okay. And this is a typical architecture. So what you do, you see here, number one, you collect the sensor inputs, in this case, temperature, humidity, and CO2. You send to this control panel. And from this control panel, you send to the cloud. And from the cloud, you can access to your handphone and your PCs or tab. And most of the decisions are made in this cloud. You have all the tools, decision support tools, image processing tools, and things like that. So you'll make all these decisions in the cloud. Okay. And on the other hand, you see this wire. These are actuators. That means if you set certain temperature value, it's a threshold value, say like 15 to 20. So if anything, out of that range, then these actuators will be on, and it will automatically doing the, for example, the irrigation. Okay. In some cases, if it's very hot, it will on the exhaust fan to pull out the hot air. So these are some of the activities will be done. Okay. And these are the robots for agriculture. So if you see the progress of the robot, so you expect in 2030 we'll have nano robots. So what's the difference? So this nano robot is as small as a dust. You can put it on each of these leaves, and you can send information status of these leaves. For example, you can use for application like plant leaf diseases. So if any of these leaf got any indication or symptom of diseases, you can send to the control center or to your example your handphone. Then the end user or the farmers can take action immediately, because like plant disease, it should be discovered at the early stage. It cannot be very late by the time the tree is gone. So if we manage to detect at the early stage, then some mitigation plan can be sorted out. Okay. These are robots for agriculture. So basically, you have all the important information on this tractor. For example, the GPS, the user interface, the steering sensors, your GSM antenna, everything is here. So basically, you can see that you won't get your hands dirty, because you don't need to really go down to the farm, and do the conventional way of farming. So you can do a lot of things through these robots. Okay, now I'll talk about the case study. So first I'll talk about the precision agriculture for outdoor environment. So in this case, what we are going to do is use the wireless sensors to identify the right time to do the pollination. Okay, because this palm tree, they have some windows of pollination time. You have to do during that time. If you miss the time, then the quality of the tree that you'll get won't be as good as the best, because the oil that you buy at the shop, the palm oil, the quality depends on the tree or the pollination process that you are doing. Okay, and then the second one is greenhouse mushroom cultivation. Okay, so this one basically you grow mushroom in a greenhouse environment. So I'll go to the first one. The pollination is an important process in all palm breeding. During pollination process, the condition need to be monitored. Okay, currently the monitoring process is very manual. So what will happen? So after say a couple of days or weeks, the person will climb the ladder, manually go to the tree and check whether it's ready for pollination or not. So they will check some parameters like the colors, maybe the maturity of the fruit and things like that. So if it's not ready, then they'll come down. Then they have to go a couple of times until they find the right time. So this is very dangerous and sometimes also consume a lot of resources. So you can see the palm tree is high as can reach as 20 meters or so. It depends in some places. And this is the risk they have to take, go up and down. So these are the current issues. The workers or the staff have to climb the tree, and then also risk of falling down. So why wireless sensor network? So it have a short receptive period, like 36 to 48 hours, like one and a half days to 2 days. Then remote monitoring system for this is good. That means you don't need to climb the tree. You monitor certain parameters. Then if you reach certain threshold value, then you can send the people to go and do the pollination. So this is the architecture, the three-layer architecture. So this is your sensors, this is the middle layer, and this is the application layer. So this is how it works. So basically what you're going to do, you're going to put the sensors at two places. One is the actual tree that you want to do pollination. One is a reference. Okay, so both of these will use the humidity sensors. So you take the reading from these two and you'll minus off. Then you'll reach a stage where you'll see there's a consistency. The difference will be consistent. That means there's no increase and reduce of the values, the difference. So once you reach this consistency, then it's the time to get the people to go up and do the pollination. Okay, the pollination is done manually. They spray some fluid or some hormones, and then you will get pollinated. Okay. So the same thing I mentioned the architecture. We use the similar architecture. So this is the sensors. This is the tree that you want to do pollination. So you wrap in a plastic. Okay. So these sensors basically collect the information about the humidity. Okay, so in our case, what we did is we collect for every 5 minutes. Okay. Okay, this is more detail about the gateways, the sensors. Okay. Okay, if you see here, the value from the two sensors will be minus. Okay, so this one is the main sensor. Okay, the value from the main sensor will be minus with the reference sensor, and then this is what you'll get. You'll see that there will be a consistent. Okay, so this consistent is the time that you should send your people to go and do the pollination. So this is the time you can see. Normally it happens like in the mornings. Okay, very seldom in the afternoon, but mornings. So if it's happened in the afternoon, you can wait also for the next day, no problem, because the pollination period is 36 to 48 hours. Okay, so you're not necessary to go at night and do this pollination because it's a bit dangerous. So you can wait the next morning, but don't miss that 36 to 48 hours time frame. Okay. So what is the result? So we tried for 69 trees and we managed to detect the pollination readiness for 64 trees. That means the success rate is around 93%. Okay. So that's the conclusion from the first case study. And then these are some of the issues. Okay. So since palm oil plantation, or if you go there, you see the leaves are very huge, and sometimes you might have some signal problems to reach, okay, to the center or the control center. The second issue is because we use all these batteries, so the management of battery is very important. But anyway, these batteries can last from 6 to 9 months. The battery can last. Okay, and in the sensor itself, there is a LED indicator. If the battery is weak, it will blink, so you know it's time to change the battery. But of course, these things need to be improved so that battery can last longer. Okay, what's the benefit? Able to trigger pollination, increase quality of yield, reduction of labor dependency, able to directly communicate with the sensor, to get real-time data using wireless sensors. Okay, this is what you use for palm oil, but you can use similar concept for other crops. If you want to monitor certain parameters, you can use the sensors and also the IoT. You monitor, then based on the values, then you can take some actions what necessary be done. And this is for the pollination of a palm oil tree. Okay, the second case study is about this mushroom called shiitake. So this mushroom is the second widely used mushroom, and it has a lot of demand in countries like China and Japan. Okay, it can reach 1 kilo like 15 to 20 US dollar. Okay, depend on the season. So it's very highly in demand for these countries, and it has a lot of qualities. Okay, it's a high protein, low fat, and also some cases they say it also can be used for anti-cancer. Okay. Okay, so the parameters that we monitor here is temperature, humidity, and also CO2, carbon dioxide. Okay, and you have to remember here they have two stages of growth. One is the what we call the incubation. One is the growth. Okay, and both of these the requirement of the parameters are different. Okay, the temperature, humidity, and CO2 requirements are different. Okay, we'll see later. So the objective we develop this in a hilly area is like what you have in maybe in Kerala you have the Munnar and maybe like Uti, but not as cold as these places. But these places are normally used for grow vegetables and yeah one of the activities they are doing is growing this mushroom. Okay. Okay, these are the various type of mushroom in Malaysia. So the one we are focusing is this shiitake. Okay, and these are some of the more details about this shiitake mushroom. The scientific name is Lentula edodes, and in fact, we in Malaysia also couldn't get the fresh one very much. I mean, it's a huge demand, so we have to buy most of the time the dried one in China, but we export the fresh one to other countries like Japan and China. So this is basically a greenhouse, but we call a mushroom house or smart mushroom house. Okay, so this is the architecture, how the house look like. So basically the surrounding of this, we will put the nettings, the dark color nettings. It's 90% dark. You can get 10% lights going through. Then of course here we have some other devices also fitted here, circulation fan, exhaust fan. Then we have what we call misting system. So if you see here, we have two portions. This is the growth area and this is the incubation area. This incubation area is fully dark. It's a dark room. Okay, here also we have some of these devices, humidifier, dehumidifier, aircon, and so forth. This is the control room. This is the equipment room. And this is a solar panel. We are using solar panel. But this solar panel is mainly to make sure we collect the data. Okay, so make sure collect the data and on some critical devices, not for every single thing. Okay, and this is how it looks like the mushroom house. This is the incubation area. This is the growth area. So when you see the incubation area, this is the mushroom seedlings. We put in a lay order, and we put in the growth area. We have to put in standing order because the mushroom shoots will come at the side of this. So if you leave it like this, it will match one another. So that's why you have to put in vertical or standing order. Okay. So this is the actual house. So as I mentioned, there are two phases in the mushroom cultivation, the incubation and growth. So each require different temperature, humidity. So you can see this table. This is the values. Okay. Growth values, and you can see it's a different day and night. So this architecture, I think I've talked about this earlier. Okay, then the physical layer is basically the sensors and cameras and things like that. Then the middle layer is the control panel, sensor managers. And this is the application manager. So basically, these are some of the apps. The apps are all developed using Android. So it's easier for the farmers or the people who are looking after the mushroom farm to manage because all the information they can view through a handphone. So you will have the current values of the temperature, humidity, and CO2. CO2 is particle per minute. Okay. So also you keep the log, the historical values of all of this. You can keep for 1 week or even for 1 month. Okay, and also you have facilities to put things like graphs. You can draw graphs. You can see how's the pattern for the last 1 week or 1 month. And at the same time here, it will also show the threshold values. Okay, if you remember the temperature, humidity values just now, you have some range. So if it's below, it will show in yellow color. If it's above that range, it will show in the red color. Okay. Okay, and at any time you can click at this graph and it will give you detail about the temperature, humidity, or whatever parameter that you want to select, and plus the timestamp. What's the time? Okay. Okay, what's the benefit of doing this? This is the outcome. So if you use the conventional mushroom house, you need to use 4%, and for each bag, the seedling I showed to you, you get 125 grams. But if you use a smart mushroom house, you only need 1% to manage, and you can get almost double of what you get through conventional or traditional method, which is 251 grams per bag. Faster harvest time, and also they increase the yield because you can get extra yield. Say for example, if you get three yields per year, three times you can harvest. But here with using mushroom house, you can harvest 4 times, for example. So you get more yield and also better quality because you are putting this mushroom in a very controlled room and you give the most conducive environment with the temperature, humidity, and CO2. Okay. And these are some of the checklists for those who are interested to do smart agriculture, the hardware, the security, data collection, connectivity, infrastructure, mobility maintenance, and also the data. Okay. These are some non-technical challenges. These are things like manpower, fear of new technology, especially farmers or newcomers. They have always this high investment. Of course, early stage you have to invest the devices. This kind of mushroom house or devices can last for a longer period. And also awareness. This is what a lot of countries are trying to do to their farmers. There is some awareness. And market is fragmented and standards, and there are not many standards. So sometimes you buy certain devices, you cannot upgrade or you cannot make it a modular. So you have to always change. But there are some committees working on these standards. And then technical challenges are the architecture. You have to know if it's a greenhouse in a controlled environment. You use different in the sense of the devices that you are going to use. And then if you are using the open environment, then you need to take into consideration about the wear and tear. Then also about the power management, your internet connectivity, ICT knowledge, data management. These are some of the issues and challenges. These are more detailed, each of the issues and challenges, the architecture, the data transmissions, okay. And of course, in some villages or remote area, you don't have this internet, so you must have some alternative for it. And I think nowadays most of the places are connected. Okay. Then your data management, since you are going to collect data every 10 minutes, there will be huge data. So you have to make a decision how long you want to keep this data. Then of course your data security. Okay, at least minimum you should have some encryption and things, basic security features. Then the power management, as I mentioned, nowadays we are using solar panels, and in some senses they are still using the batteries. So if you are using the battery, there should be like an indication to say that battery is going to need to be changed or replaced. Okay, some kind of user-friendly interface to show to the farmers or end users that it's time to change battery. Okay. Then of course your internet connectivity. Okay. And of course the ICT knowledge in some cases. Before you implement the system or put on the ground, we need to train the farmers how to use the system. Okay. And this is the conclusion. So as I mentioned, by 2050, we need to increase the farm products 70%. Future farms are going to be small, integrated, and technology-driven. Besides WSN and IoT, you also need technologies like AI, robotic, drone, okay, machine vision, big data. So it's integrated of many technologies that are going to be deployed in the smart agriculture. And then finally, the issue I highlighted need to be improved in order to enhance the application of ICT or IoT in the agriculture, and finally to meet the procurement. Okay, I think that's the end of my presentation. We have time for any questions. So now you can ask if you have any questions. So any questions from the participants? So,
Hello,
yeah,
sir. This is audible, sir.
yes, yes, I am audible. I have just
Yeah,
concluded the
thank you, sir. It's my
presentation.
honor to extend our heartfelt gratitude to all who made today's event successful, sir. My
Okay.
esteemed,
Yeah,
thank
thank
you,
you.
sir, Mr.
Yeah, thank you. Thank you very much. Thank you very much.
Yes, sir. Yes, fine, sir. A special thank to you, sir,
Yeah, thank you. Thank
for
you.
this wonderful event.
Okay,
Thanks a
thank
lot,
you very
sir.
much. Thank you. Thank you for inviting
Yeah,
me.
fine.
Thank
Thank
you.
you.
Thank you. Okay, bye. Okay, thanks. Okay, thank you.
Only
Okay, thank you very much, Mr. Rajarajan. Thank you.
Good morning, everyone. First of all, I would like to thank Dr. Kodishwaran for giving me an opportunity to be a keynote speaker for this IEEE International Conference on Smart Technologies for Sustainable Development Goals. And I feel that this is the right conference at the right time when a lot of talks are being talked about, a lot of talks are going on this sustainable front. And incidentally, this will definitely provide a good interface between the educational institutions and the industry, because a lot of things are happening in the industry, and of course the syllabus for the engineering curriculum cannot constantly be updated. So naturally, there is a need for proper interface between institutions and industry, and which should happen constantly. So such conferences really provide a good platform for students to understand what is happening across, and gives a good idea of what lies in future. So once again, I thank the organizers for giving me this opportunity. Of course, as part of Larsen tomorrow, I would like to tell you that we have a division called L&T EduTech, which constantly conducts certificate programs and all that in latest technologies, particularly artificial intelligence, cyber security, semiconductors and solar and things like that. So if you go to the website, you will be able to find out what are the things happening. It will be it has got a real-time connotation to what we are talking about. I take this opportunity once again to wish the function all success, and I am sure there will be a lot of takeaways with eminent speakers all around. Coming to last two, very specifically I would like to talk to you because technology is ever changing and it is going in exponential manner. To just quote one sentence by Mr. Satya Nadella of Microsoft, when he said that in technology we are only as good as what we do next. That clearly indicates that it's a constantly moving one, and unless you keep abreast of what is happening around, you can't move forward. So in that manner, Larsen & Toubro Smart World and Communication Division was formed specifically for the improvement of the life of citizens and used technology for better outcomes, so that the living becomes more comfortable. I am happy to tell you that we have touched the lives of more than 150 million people in the country through our safe cities and smart cities and all that. Almost about 27 smart cities we have completed, which is one of the largest. But the smart city, the conceptually had like every city came out with the pain points of that particular city, and then we went for digital intervention, and then we provided outcomes which were measurable. So using technology, how to improve the quality of life. This is what we have been doing all along, and recently also the government has announced another 12 smart cities with good investment, and these augurs well in the days to come. Some of the important solutions that we have given, which worth mentioning here, is that one of the things what the problem statement was that there is going to be a huge crowd in Kumbh Mela, which is one of the major gatherings in India where people come for holy dip. Now here we wanted the crowd to be managed, so we used a software which there are multiple lanes, if I put it that way, multiple lanes where people go and have holy dip. This software will find out the crowd level, and the moment it reaches a particular threshold, it will advise the people through video screens and mobile phones and all that to go to the next lane. And this way the police were able to control it so beautifully. It's an automatic sort of control, and in a span of about 45 days we had about 27 crore people, and on a particular day there was almost about 3 crore people, and the entire thing was done in a seamless manner and without any incident, and we created a control room which was subsequently being continuously used, and this was also used for lost and found and serial killers finding and all that. So this is something which we did for Kumbh Mela. And another thing we did in Mumbai, we put about 5,000 to 6,000 cameras using number plate. we put number plate recognition, then automatic, violation detection and all that, and including a dial 100. Where if somebody has got a problem, they give a ring, and within 6 to 8 minutes, the police is able to go and then save them. So this is like this. In every place, we put the solutions based on the requirement. And another one particular thing is that early warning dissemination system which we did for Odisha and Andhra Pradesh. That is, during the cyclone, how do you warn the people so they go to the shelters on time? This is through always, of course, the mobile phone, and we had towers across the coast where your radios were provided which will communicate to the people to go to the shelters. And one of the important technological thing what we used was this location based sensing, which means you have a coastline of about 500 kilometers and you want to communicate only about, advise only about the range of 45 kilometers people to come and go to the shelter. You have something called location based sensing, where you draw a polygon in the control room and it only transmits signal to those mobile phones which are connected to that particular stretch of about 30 or 40 kilometers with we choose. Why I am mentioning all this is that depending on the requirement, the problem statement, we will be able to give digital interventions to provide an outcome which is of course measurable. And so in the days to come, technology is going to take a major role, and another thing which we have done is that on 5G part of it. 5G is all about high speed and low latency. We demonstrated 2 or 3 things. I will try to share 1 or 2 things with you. One is actually the connected ambulance. You have an ambulance, the patient gets in, and then the whole the cameras and other things are operated through 5G, and immediately the signal is transmitted to the doctor wherever he is, and he starts interacting. Because of the high speed and low latency, you have a feeling as though the doctor is sitting in front of you. And in another case where we had in our own factory, where we were using special cameras for welding. I mean, using that, we used to take the images to the control room, and the welding used to be controlled because of the highly sensitive kind of welding. Instead of using Wi-Fi, we started using sort of 5G, which is used to a private LTE. With that, we could find out the images were clear and the transmission was faster, and because of the low latency, the productivity went up. So in the days to come, and more and more such things are going to happen, and with the technological developments, even in industry, probably if you take industry 4.0, that is also going to take a different dimension. Because assuming the process takes about, let's say, 100 seconds or 200 seconds, using 5G, the whole process can be made faster. And if 200 seconds becomes about 150, 160 seconds, then your productivity of the whole process goes up. So, another interesting project what we have done is the smart metering project which we have done in India, because of which the losses we could bring down substantially. All these energy saved is energy generated sort of. So all these make the whole thing, sustainable. And when the smart metering, what we have done is it's an automatic connect, automatic disconnect. I mean, there is a load profile which is available to them in the mobile app, which they will be able to find out which equipment, if they use, what is the unit being spent, and they will be able to do their own load management. So I think these are some of the things which we have done as part of the smart world and communication business, but in the days to come, this is going to be the future. It is all about putting a sensor, putting sensors in the right location, take the input, analyze the data, and then it's a question of machine learning, artificial intelligence, and then make useful outcome so that the productivity becomes better, the sustainability is there. And of course, one of the important things what we have done is that automatic traffic control, your ADCC, which we have done. That is that whenever you travel, you find the signal sometimes it's red, and on the other side there may not be any vehicle coming. So what we have done in Nagpur is that we have put the cameras which would find out the number of vehicles, density of the vehicles, and then it will determine when the red has to become green. With that, you are able to go faster. This really ensures that proper carbon footprint, and this is again ultimately the sustainability and the environment protection what we are doing. So I think like this I can go on and on. There are multiple things which we have done in LLT, and there is a requirement across the world for all that. So I would encourage students to probably study different areas. It could be industry, it could be city, it could be a colony, and then find out that what probably could be done to improve the quality of life of citizens, and I tell you there is technology available in that. So I thought I would take this opportunity to share a few thoughts from my side on what Larsen & Toubro has done and what the world has got for you, and I'm sure more such views and thoughts will be shared by several of the eminent speakers here. I'm sure you would find the whole the conversation very interesting, and unfortunately I couldn't be present personally here because I am out of the country, but I would definitely like to have the next opportunity to come interact with you and probably take your questions and then answer. Once again, thank you very much for this great opportunity. Good luck.